Hey guys, my name is Sandeep Patel. I'm founder and CEO of Slotify.ca. In this video, we are going to learn an important sorting algorithm called merge sort, which is used for array sorting, right? So the merge sorting is using another technique called divide and conquer technique, right? Under the hood. So first, in order to learn merge sort, we first have to understand what is a divide and conquer technique, right? So basically, this is an example here. An we have an array called 53842, which is unsorted, and we can either sort this using ascending or descending order when we use merge sort, right? So let's first understand what is the divide and conquer, right? So the idea is that dividing means splitting array into two halves, and conquer means we can, while we split the left and right part into a smaller subproblem, we can then solve that subproblem, right? And then combine those subproblems at the end using merge operation, right? Let's understand in a bit more depth. Okay, so first of all, let's understand what is a divide. Um, so the divide step can be divided into two more steps, right? So how can we divide an array, right? So there are two ways you can divide array. You can use either like half of the size of the array and then divide, or you can use an pivot element from which you can divide left and right part of the array, right? So there are two methods, right? So first method, halving an array, right? So we're gonna use that method in this video, right? In merge sort, we use a technique called halving the array, right? We pretty much divide array into two parts, and the pivot, using the pivot technique, we're gonna use this technique in quick sort, which is my next video, right? All right, so you have to remember that in merge sort, the divide operation uses a technique called halving array into two part, right? Okay, so when we halve the array, we get two part, the left part and the right part. So basically, we divided array into two parts, left and right. And then what we do is, now that we divided the actual problem into sub problems, right? Then we're trying to solve the sub problems, right? So we're gonna continuously multiplying left and right array. So there should be a point where we stop halving the arrays, right? So that's like termination point in divide and conquer method, right? So that we can call that as a base case, right? And the base case should be like when array is empty, or either it can have a single element, or the array size would be the small enough so that we can solve the problem, right? So this is a really core technique in software development. Like you have to first divide the whole problem into a sub problem and then try to solve the sub problem. So this technique you should definitely know, right? Okay, let's understand a bit more. So let's say that this is an array 53842. So this is a real problem, right? So this is a bigger problem, but our goal is to first divide that big problem into a sub problem, right? So can we say that, like, instead of solving the whole array, if we had only two elements, can we solve this problem, right? Let's say if we want to sort array with two elements, can we do that easily, right? Yeah, we can, right? We can just move the smaller element on the left side and move the higher element on the right side. We can just do one swap, and then we can solve the sub problem, right? What if you have array with only one element? Can we say that if we have array with a single element, it is already sorted, right? So this is our base case, right? So if we can solve subproblem and the base case, right, then we can definitely solve this problem. How? Let's look at this. So now we have the array of 5 elements, right? So idea is that in the merge sort, we can divide this array from here, right? So in the midpoint. So now the left part is this, right part is that, right? So now this array is divided into two subproblems, right, with two elements, and we know how to solve two elements easily, right? Even if we divide this into a really smaller problem, then we can say, okay, because the single element is already sorted, we can when we hit this base case, we can return, and then we know how to solve two single problem, right? We can just swap the higher element on the right and lower on the left side. Okay, so this is the technique that we're going to use in the merge sort. All right. Okay, so now we actually follow the merge sort, right? So how are we going to do that? So we have this problem 53842. That's a array with the 5 elements, right? So we're gonna take the midpoint, which is 8, right? And then divide this problem into subproblems, right? So we're gonna divide this, let's say, um, into two problems, right? So we're gonna say, okay, 53 and on the left side and 842 on the right side. So now we have this 5 3, we can divide into a smaller subproblem, right? So this is a base case, so we hit the base case here, and then this we're gonna further divide into a single and a two element, right? So single element is already sorted. When we have two elements, we can further divide into a single element, right? So now at this point, what we can do is we can return here, right? So from here, let's say that we now want to merge this, right? So how are we going to merge? So in the merge operation, what we do is we take the lowest element on the left side and the highest element on the right side. We can just do swap, right? So for example, when we do a merge part, our new array will look like this, right? All right, so when we do a merge operation, right? So this array will be sorted in 2 and 4, right? Okay, so now that we solve this problem, we're gonna go higher up, right? So now we're gonna solve this problem here, right? So 2 4 is already sorted here because we returned in here, and now we have this 8 on the left side. So we're gonna move this and sort this such that our merge operation is now look like this, right? So we have 2 and 4 already sorted, and we move 8 on the right side, right? So now we have 2 4 8 sorted, right? So we're gonna go further up and solve this problem, right? So in here, so when we hit this base case, we already did we already sorted this part. Let's say that when merge operation runs here, so this becomes 3 5, right? And then this returns at 3 5 here. At this point we have 2 4 8 already sorted. So let's say that we move this sorted array here, and then we also move 3 5 here, right? So now how do we merge this, right? So what the only thing we have to do is that moving smaller element on the left and higher on the right, right? So when we merge these two, it becomes okay, let's say it becomes, so we have two already in order. Now we move 3 in here, right? And then we move 4 on the right side, 5 on the right side, and then last element 8, right? So now we have sorted array at the end, right? So this is how it's done using merge sort. Okay, so now we have to calculate the time and space complexity, right? So how do we do that? So first we have to understand that at each level, so let's say this is our first level, right? At this level we have only one part, right? So let's say 2 raised to 0 equals 1, right? Then we took this problem and divided into two subproblems, right? So now we have two subarrays, right? Which is 2 raised to 1 equals 2, right? And then we further divided this into every step it just double down the problem, right? And so at this stage 2 raised to 2 means 4, so you should have 4 elements, so 2 element here and 2 here, right? This is combined, but it's still two part, right? So you can say at each level the calls are getting doubled, right? So when the calls are getting double, that means we have to take the whole tree into an account, right? So this becomes 2 raised to 0, 2 raised to 1, 2 raised to 2. If we have a big problem, then it's going to go from 0 until 2 raised to, sorry. So this is going to go from 2 raised to n, let's say. If we have array of length n, right? So 2 raised to n. So if we take a log on the 2 raised to n, if we take a log, that becomes log base 2 of n, right? Log n of base 2, right? So basically the number of calls or number of levels that we have with the array of size n would be log of n, right? So you remember this, right? Whenever we have the tree like this, which divides problem into two problems, subproblems, then you can easily call that the number of call would be the log of n, right? So just remember this. Let's solve the problem first using code, and then we'll come back to this. Okay, so let's write the code first, right? So as I said before, if you remember, so first thing we need to do is that we need a logic for the base case, right? And what is the base case, right? When we have single element, right? So can we say that if array dot length less than equals 1, right? Then what we can do is just to return the same array, right? Because it's gonna have a single element, right? So we solve the base case, right? Now in merge sort, as I said before, there is a divide step, right? So what is the divide step? So basically divide array into two parts. And how do we do that? So we can say, okay, this is a middle index, and we can do math.floor function, and we can take the array length and then divide by 2, right? So this is the divide step, right, where we divided array into two parts, right? But this will give you maybe in the decimal value, and that's why you use floor, right? Just so that we can round it up. Now the idea is that from here we can get two parts. We can get left and right array, right? So how do we do that? So let's say constant left array, which is, we're gonna call the same merge sort function, right? And then what we do here is that we slice the array, right? So we sliced array from 0 to mid element, mid index, right? So that's our left part. Our right part would be right array equals merge sort array dot slice from mid index, right? So if we do that, this is gonna go from mid index until end of the array, right? So now we have array, this array. Let's say if we take example of this array here, right? So let's say we have this array here. So now what we did here is that we divided this array from 0 to mid index. So let's say that this is the mid index, right? So we're gonna cut this array until mid index, which is this, right? And then what's left here is that we have 5 and 8 left here, right? Make sense? Okay, and then let's go down. Now we have to solve this problem, right? The last step would be the combine step, right? So in the combine step, what we are doing is basically merging two arrays, right? And how do we do that? So we're going to create another function called merge, and then we pass left array and then right array, right? And this is where we are trying to solve our sub problem, right? Okay, so let's create another function called merge, which take array 1 and then take array 2 and then it is going to return a new array, right, which is a combination of both. Okay, so if we want to merge two arrays, first we will take another array called result, right, which is a number array, and then so which is empty in the beginning, right? And then what we can do here is that we can take two variables, let I equal 0, let j equals 0. Okay, right? And then what we do is we can do a while loop, and then we can say that if I less than array1 dot length and j becomes less than array2 dot length, right? So until this variables are less than the actual length of this array1 and array2 length, we're gonna run this loop, right? And then when we run this loop, we can basically say, okay, if array1 I, if less than array2 of j, so we can say if like the element from array1 is smaller than element on the array2 on the same index, right, same index 0, then we can say just push that new at that time we can push this element from array1 into this new array, right? And then we can increase the index so that we can move to a next element, right? And let's say that if this is not the case, that means this is smaller, right? So in that case we can push array2 element, the jth element, right, into this result, and then we do j++, right? Okay, so what happens when you have, let's say that this element, this array has 2 elements and this guy has 3 elements, right? But this will run out at some point, right? So when this run out, there is still 1 element in this array, and that could be a vice versa, right? And this might have 3 elements, this might have 2 elements. So we need to consider the case where the I still has, like this array 1 or array 2 still have some element left, right? So how do we do this? So let's say return result, and then we concat, right? We concat array1s, whatever the elements, we can do a slice until I, right? So what this does is that, let's say if there are 3 elements and we only loop 2 elements, there's one more element, right? So let's say it becomes 0 and 1, and now it's at index 2. So from index 2 we cut all the elements, right, the rest of the elements, and then we can also concat same thing for array2, right? Array2 dot slice j. So this will cover the case where even if this array1 or array2 has some elements in it, it is going to cover that scenario, right? Alright, so let's run the code and see what happens. Okay, so when you run the code, this is unsorted array, and now it's sorted in this order, right? 2 3 4 5 8, 2 3 4 5 8, right? Okay, so now the important part is how are we going to calculate the time and space complexity, right? Okay, so first of all, let's try to calculate the time complexity of this code, right? And then space complexity of this code. I want you to access this function. Assume that this function is a separate function and you are trying to find out the time complexity of this, right? So in this case, you have 2 different arrays, right? There are 2 different arrays, and there's a result that is combining both arrays, right? So let's say that this is n. Assume that n equals array 1 length and m is equal to array 2 length. So in this case, this result would be O of n plus m, right? So we are basically storing n plus m elements in this result array, right? And then how long this while loop will run until we have array 1 length and array 2 length. In this case, the array 1 length is, let's say that this is n and this is m, right? So basically this loop will run until O of n plus m, right? So basically the complexity of this while loop, right? Let's say this is a one unit of time. So that operation is 1 unit of time. If this is also 1 unit of time, like all this statement, they're 1 unit of time, right? So they're going to be multiplied with this while loop, which runs on n plus m time. So n plus m into 1 becomes n plus 1, n plus m, right? So overall complexity of this while loop is O n plus m. So I would say that this is the time complexity, and this is also same for space complexity. Why? Because we are returning the result array. And what is result array? So result is a dynamic variable that depends on the size of n plus m, right? We are basically pushing n plus m element into this result, right? Okay, now assume that this function, let's calculate the time complexity of this function, merge short, right? So let's say that this line of code runs of 1 unit of time, right? And this is also 1 unit of time, right? Now this is interesting part here, right? Basically we are dividing the same input into two parts, right? Left and right. So this, if we go back here, we saw here that like the main array was divided into two subproblem, and then that problem is divided further into two problems. So it becomes a binary tree, right? Which has a depth of 2 raised to n, I mean log n. So you can assume that this 2 operation, right, it's a log of n, right? Because it's basically splitting the tree into 2, right? And now this merge operation, right? We found out that the complexity of time and space complexity of this merge function is n plus m. But what if the left and right array is the part of the same array, right? In this case, n equals m, right? And basically this is the same array, right? Like the main array was divided into two subarrays, right? So you can take n equals m or m equals n. In this case, instead of O plus O n plus m, this becomes O of n, right? Because n and m's are same, right? It's a part of the same array, right? So you can say that the merge operation runs on time complexity of O n and space complexity of O of n, right? So now overall time complexity of this merge function overall means we're concerned about the big part, right? The big part that is taking the larger space. So in this case, this log n multiplied with O n, that becomes n times log of n, right? So that is the time complexity of this code, right? And what is the space complexity? So space complexity coming from this merge operation, right, which is O of n, right? So n is larger than so you can say that this is call stack also count towards the space complexity, and call stack in this case takes log of n, right? But there's a higher term here, right? Like n is higher than log n, and that's the reason why we consider the space complexity to be n instead of log n, right? So yeah, so this is how you can find out. Sorry, this is how you can use merge short algorithm, right? I hope you really like this video. Please like, comment, and subscribe, and stay tuned for my another video on quick short. Thank you.